Hello again, this is Franklin, and I'm giving a class today on the multimeter, on how to use it for checking heavy equipment and construction equipment. We will not go over household AC power testing it with the multimeter, but I'll just give you a short rundown what it's used for. Give me a minute and we'll get started. Now these are the two multimeters I use for work. I use this one here, and I use this one right here. Now basically they are the same. The main difference is this one is a cheaper model, and also it has the probe for checking amps, and I'll explain to you the difference between checking amps and not. This one here, in order to check amps, you have to purchase a different type of a probe and plug it in right here, and you can check DC and AC amps. This particular one right here checks DC and AC amps, which is the only way you can determine whether you actually have current flow, is to check and see how many amps you draw. Now this one right here is a Fluke, and it is pretty much top of the line when it comes to multimeters. It's very expensive. I was issued one back in 1982 by the military, and 5 years later when my duty station was up, it was still working. So I chose to pay the lost meter fee, and I took it out of my paycheck and I kept it. And I took it to my next duty station in Colorado. I had it there for 5 more years until I was discharged. And it still worked 10 more years after that. So I had the same meter working for me for 20 years, and it was a Fluke. Now this one right here, I bought at Lowe's for, I think it was like $50. And it works, but I've had a few of those. They just don't last very long. Now this particular meter here usually costs around $700 or $500. I'm not sure what it costs these days. But I bought it at a pawn shop for $25. They don't usually know what they have, and they don't give up $5 or $10 for it because the person who took it to the pawn shop probably didn't buy it. So I bought this one at a pawn shop. I actually ordered this one right here on Amazon for sorry, I didn't buy it at Lowe's. I bought it on Amazon. The one before this one was the exact same brand, but I bought it at Lowe's for twice as much. And the reason I bought this one specifically is because of this right here. This is an amp probe. And the reason you need an amp probe is because, say you have an alternator on your car, on a bulldozer, there's an alternator that's bad. You can put your meter test leads on it and see it's putting out 12 or 13 volts, but you don't actually know that it's charging. The only way you can actually know that it's charging is to determine how many amps the battery is drawing from the alternator. So you would actually clamp this over the positive lead, and I will show you how to do it in a minute. And you can see it'll show here amps on the digital meter here. Now when you purchase one of these, you got to be careful, because see this one here, it has, see the amps, AC, you see it has a straight line on top and a slant line on the bottom. That means this one does AC and DC amps. And most of the time when you buy them, it'll say it tests amps or AC amps or DC amps in separate locations. Like this one right here, you see it says, this particular symbol here, it says it tests DC amps and it checks AC amps. But this one here, you gotta buy another probe and put it right here, which at the pawn shop it was not there. When I was in the military, I had my issue, it was issued with everything. The only problem with that is keeping up with them. The probe was separate. It had this probe, but you plug it in there, it was separate. On this one right here, it comes as one piece. The only thing you got to be very careful when you buy one, because 90% of them do not do DC amps. When you purchase one, normally it'll just have this A with a slant, and you don't want to buy that one unless you're working in a plant that has electric motors and pumps and things like that. When you have a bad electric motor, you clamp it on there to see if it, on the side of the motor, it will say, like if it's a 1 horsepower, it'll say 1.8 amps full load amps. So you want to check, you put the probe on there, and if it says it's drawing 10 amps, that means it's got a ground, the motor's no good. Or but it's not showing anything, the motor's no good. That's for an AC motor. But we are doing heavy equipment. There's no AC current involved. There will only be DC. Normally 12 volts or 24 volts, and sometimes the electronics are digital impulses. So what we got here, if you look at this one right here, it says amps, AC, and DC. You clamp this on the line the positive or the negative, and it will show you how much current is actually drawing through the line. And if it's drawing current, that means it's actually for sure charging the alternator. So this position right here, if you see that, that's AC volts. For checking your house current, you can check your volts on your house. If you have 110, it probably has power. If it doesn't have 110, then you don't have it. And this one here is volts DC, and that you use for checking your battery to make sure you have 12 volts, because you can actually have 12 volts in the battery, but it still won't work because you won't have any current. It just won't. You can put the wire straight across it and it won't even spark. So just because the battery has 12 volts, that does not mean it works. 90% of the batteries that are bad will actually show that they have 12 volts, but they still are no good. And some also do not hold a charge. You can show 12 volts when you charge it up and it'll work, but then as you disconnect it, it starts discharging. That means the battery will not hold a charge. Okay, we have frequency here, and we use that only for generators mostly. And in the US, we have 60 hertz. In Europe, they use 50 hertz. And in the military, some generators are at 400 hertz. But for our purposes, we will not have to use that. And this also has the ability to check temperature. You see, Fahrenheit and Celsius. However, you have to put on different probes, not these. So, and we'll go over here to the fluke. You see we have AC voltage on top. That's for checking household current. And you got DC voltage here. And that will check your batteries, 24 volt, 12 volt, 10 volts, whatever. And then you got millivolts. And that's for checking like very, very low voltages, which we will not be using because you will be checking mainly 12 or 24, not millivolts, not tiny voltages like 0.5 volts and 0.6 volts. Okay, and this one you will use, that is resistance. All the machines these days, most especially the hydraulic ones, the big machines, have solenoids that pull up a spool and engage hydraulic flow. So coils are very common in cars and in machinery. So, but on the side is usually marked how much resistance it has the coil, and usually from 5 to 30 ohms, depending on the manufacturer, and depends on how many coils it has. If you put a test meter on a straight piece of wire, normally you get 0 ohms. But after about 10,000 turns of wire, that means there's a lot more resistance because there's a lot more conductor. So this is for use for checking coils and wires, solenoids. And this one is for checking usually fuses. You can check your fuse with ohms too. It'll read 0 ohms if the fuse is good. And this one right here, you can check fuses and diodes. But the difference is, on this setting, you don't have to stand there and hold you can just put it there, you can hear it. On this setting, it's the same as that one basically, but it just tests continuity. Hear the beep? The two lines are together. Checking the fuse, and you can't really see it, the meter. You can just hear the buzz, and you know it's a complete circuit. So if you're checking a wire to make sure it's not cut, and you just put it on one end on one wire and one on the other end of the wire, and and if it beeps, that means the wire is a complete circuit. So, in short, this one here is for continuity. Now, if you have a wire, you want to know if it's open, you put one lead on the wire on one end and the other lead on the other end, and if it beeps, that means you got a complete circuit. The wire is not open. However, if you put one lead on the ground and you get a beep, that means the wire is actually grounded out to the frame somewhere, just so you know. And you see that OL? That means open line. So it's not continuity. When you put them together, you notice it goes to 0. That means no resistance at all. Okay, and back to the reason I use this one right here, because it costs a lot more money to buy a new one, and it's actually more precise than that one. Checking resistance, voltage, and everything is a lot more precise. It's a much better machine. If it costs, usually they cost from $500 to $800 brand new, but of course I bought mine at the pawn shop. This one here works okay, but the reason I have this one is it has the probe, the amp probe, and this one does not. I can buy the external probe for this thing, but it was cheaper to buy this, and I use it also. And I'll keep this one, I'll keep the other one here kind of put to the side. Okay, we're gonna go over our AC first. You see this plug here? This is a 4-wire plug. So we have a hot, a neutral, and a ground. So 2 hots and a ground. So this is a neutral. Neutral with that hot is 110. Neutral with that hot is 110. 2 hots together, which will give you 240. So, and this one right here, what they call a welding plug, basically for welding machines and so forth like that. So we got 1 hot, and a ground. No neutral, so you won't get 110 out of this plug. And this particular plug here is a hot and a neutral. Okay, and a ground, of course. So if you put 1 lead here, and 1 lead here, what do you get? 237 volts. Okay. Put 1 there, you get 119. And take this one and put it over here, and this one here, you get 119 again. 1 here and 1 here. See that? 237. This one here, these are AC volts though, alternating current. 1 there and 1 there. 118. Okay. Okay, as you can see, that was done in this AC selection right there. That will give you alternating current check voltages. That's only for checking in your house. It will not work on machines or anything like that. To work on machines, you have to put it here to DC volts. See that straight line on top, dots on the bottom? That means volts DC. Okay. Now this battery here is volts DC. Okay, so you notice that one there has a little positive sign. I don't know how good you can see it. That's a positive. And that one is a negative. Now, if you were to put the wires in reverse, nothing will happen. It will just, the meter will read a minus instead of a plus. That means it's backwards. But it still read the voltage. So let's put this red one here, positive. And we'll put the black one over here, negative. DC voltage. It reads 4.1. The battery's almost dead. Okay, so if it would fully charged, it would read 12, but it's not fully charged. Okay, now if you were to put the red one here and the black one on this side, it will read the same thing, but it will give you a negative sign below it, showing you that you got it backwards. But it would still read the same voltage. Okay, let's put this under there and tighten it up good so it can come out of there. Okay. You see? Same voltage, 4.1. You see this little negative sign right on the side there? That sign right there? That means the wires are backwards, but it still reads 4.17. Doesn't change the voltage at all. Okay. Now, I'm going to show you what this one here is for. This one's for reading resistance. Okay, now we're going to check resistance. Okay, this is ohms for resistance. Okay, now let's say you got a wire in a machine. It goes along, well, you can't really see it because inside of the black insulation and everything. And you want to see if it's cut somewhere. So you find one end on the diagram and you find the other end. You put it on resistance, or you can put it on continuity, which this is a beep. Lets you know the wire is complete. So we'll start out, and then you will put one lead on one end of the wire. Okay, now if you notice, I have one lead on one end of the wire, and I'll put one lead on the other end of the wire. You hear it beep, and it shows 0 ohms. That means it's a complete circuit, and voltage can travel from one end of the wire all the way to the other one unimpeded, because it's not cut. Okay. Now, what we're going to do is check resistance. It should also read 0. No beep, but still 0 ohms. It's the same thing. Just that sometimes you can't see it because your arms are like carrying something, you're working real hard. So you want to put it in continuity so you can actually hear it and you can tell it's a complete circuit without actually having to look at that meter right there. And also go checking fuses. Okay. Now we're going to go over to the coil. Okay, now this is a coil. These you encounter in a lot of machines, for hydraulics especially, for transmissions, inside of cars, for different things, especially inside of bobcats, skid steers, loaders, backhoes, whatever. All of them have coils in them. And what these do, you can't see it, but this one has 2 coils on it. So it'll pull a spool that way, probably forward, and pull a spool up for reverse. 2 different functions. So they're usually 12-volt coils, and basically what a coil is thousands of turns. So you have a wire. You turn it like 1,000 times around an iron rod, it produces a magnetic field, and it pulls up the spools. What it does is, these coils go all the way around like 1,000 times. You put 12 volts to it, it makes it magnetic, and it pulls up the spool and lets the hydraulic fluid flow through. That's how it works. Now, each manufacturer is different. Depending on how many turns you have in the coil, that will determine what the resistance is. So to determine if a coil is good or bad, normally you check the resistance. Most are from a 0 to 5 or 0 to 10, 5 to 10. This particular coil here, most of the time you have to get a hold of the manufacturer to find out what it's supposed to be. Or, like in this case, you have 3 coils. So, you got 3 coils that have the exact same part number, so you know they're going to have the same resistance. So you put it on ohms. And right now it's reading open line because the lines are not, it's open. They're not touching anything. It's open. Okay. Now, you're going to take 2 of these. Okay. If you look at this coil, you see I have one on one pin and one on the other pin. It says 30 ohms. Okay. To know if 30 ohms is good, you check all 3. If you get 30 ohms on each one of them, then you know 30 ohms is good because they have the same part number and they all should read the same. And we got 30 ohms. Okay, as you can see, it has 30 ohms. So, both of these have 30 ohms. All 3 of them have 30 ohms, so that means that one's probably good. But, normally what you're going to have to do is you have to check with the manufacturer of it. Most of the time I just put in the part number and Google it. Or I try to find one. I'll come to the manufacturer and ask what the ohms is supposed to be. But 99% of the time, if you look in your workshop manual, it'll say how many ohms it's supposed to be. The most common is from 5 to 10 ohms. But when they're bad, it's going to be usually open line or 10,000 ohms or 1,000 ohms or 0. It's going to be completely shorted. If you get one that has continuity between any pin and ground, then it's bad because that means it's grounded out. So that's one purpose for us using the resistance. There are other things for checking fuses and relays and so forth also, but the most common in heavy equipment will be checking these coils. Okay, now we're going to test the amp circuit. Now this particular meter here shows AC and DC amps on the same one. Normally, there's a setting for AC amps and a setting for DC amps. But this one has a little squiggly line on the bottom, that means AC, and the dotted line on top, that means that's DC also. Now, the only way you can know for sure that your alternator is charging to know that actually current is going through it. So, the only way you can find the currents going through is to get an amp meter. You see how it reads 0.30 whatever, which is basically 0. Now watch what happens when you put it on here. I clamp this on. Okay, so it's drawing from 15 amps, 12 amps. That means this alternator is charging. It's charging 15 amps. It's fully charged, so it's not going to be charging much. So, if you look at it, it's charging from 11 to 12 amps. See 11.8, 12.8, 9.8. Now if you were to go in and cut on the air conditioner, it would go up. And the reason it's not charging much is because the battery is fully charged. If the battery was dead, it would be charging a whole lot more amps. And that one's not connected. This one is. And that one says, okay, it just went up. Now it's charging 28 amps. See that? Probably the air conditioner kicked on. Air conditioner kicked on, so it's going to draw more power from the battery. It needs more power. This battery is actually small for this truck. You see 25, 29, 28. It's drawing. That's how many amps it's actually drawing. The battery is drawing that to recharge itself because the air conditioner is drawing power from the battery. The alternator is putting it back in. I take it off, 27, take it off, 0. Okay, that's what the amp meter is used for. Okay, that's pretty much it for this video. Thank you for watching my video, and please hit that subscribe button, give me a like, give me a thumbs up, please, if it was anything good at all, and I'll see you in the next one. Thank you very much. Bye.